Let us see some examples on sampling theorem. So far we have studied. The first problem is as follows. Calculate the Nyquist rate and Nyquist interval for the following signals. So, there are around 4 signals which we will see on the board, different types of signals. We will calculate the Nyquist rate and the Nyquist interval. Okay. Earlier we have seen that the Nyquist rate is should be twice the maximum frequency of the given signal. So, let us denote this Nyquist frequency with a letter capital letter N. Otherwise, you can just directly write saying that Nyquist rate is equal to 5. Similarly, what is called as a Nyquist interval? Nyquist interval will be, let us denote N here again for Nyquist interval. This will be equal to 1 by Fn. So, this is equal to 1 by 2Fm. So, if you look at this formula, the main constituent of this formula is we should know what is the maximum frequency of the given signal. Once you know the maximum frequency of the given signal, you can calculate the Nyquist rate and also you can calculate the Nyquist interval. Okay, let us start doing the first problem. Okay, in this A, okay, part A of that, there is a signal given here which is equal to 3 cos 500 pi t plus 5 sin 200 pi t and 5 cos 100 pi t. As you see here, this signal is consisting of 3 different cosine signals having 3 different frequencies. To calculate the Nyquist rate or the Nyquist integral, first of all we should know what is the maximum frequency of the given signal. Now, because the 3 components here, let us calculate 3 different frequencies and identify which is the highest frequency. Okay, in this first f1 we can call this as equal to 500 pi by 2 pi. So, this is equal to 250 hertz. Okay. Similarly, I can calculate f2 for this is f1, this is f2. So, let us say that is equal to 200 pi by 2 pi. So, this is equal to 100 hertz and f3 is this is equal to 100 pi by 2 pi. So, this will be equal to 50 hertz. Okay. So, we have 3 different frequency components. So, one is 250 hertz, second one is 100 hertz, third one is 50 hertz. So, if we look at this, this happens to be the maximum frequency. So, let us identify this as maximum frequency. Now, what is the sampling rate of the Nyquist rate? Nyquist rate we have just written, let us write it again. So, Nyquist rate is equal to twice the maximum frequency. So, what is twice the maximum frequency? This is 2 into 250 hertz, that is this is equal to 500 hertz. Okay, similarly, I can calculate what is the Nyquist interval. So, what is Nyquist interval? This is equal to 1 by 2 Fm, that is 1 by 1000, that is seconds. 1 by 1000 seconds. So, you can calculate this, you can get the answer. So, this is the Nyquist interval. So, you got a Nyquist rate, you got a Nyquist interval. So, the basic idea or the basic concept of this type of problem is from the given signal identify which is the highest frequency. Once you understand what is the highest frequency, then multiply it by twice. So, you will get the Nyquist rate. Then similarly, Nyquist interval 1 by 2 Fm. So, we got this. So, this is how. So, if you look at the other 2 problems which you are going to see, they are almost similar, but the only thing we have tried to do here in the examples is we are trying to find out Nyquist rate for different types of signals. So, that it will be a sort of practice for you, so that you can easily calculate whenever the question is given. Let us see the second part of the first question, B. Okay. So, what is this given? X of t is equal to 2 cos 400 pi t plus 6 cos 640 pi t. So, this is same question almost as we have done in the section A. So, let us do this as a practice question, so that within 1 or 2 seconds you can finish answering this type of questions. So, let us first identify again here. So, you can calculate f1 from this, you can calculate f2 from this, then you compare these two, then you will get fm, then multiply that fm by 2, you will get the Nyquist rate. Okay, this is the algorithm, or these are the steps which you have to follow. Identify the frequency component f1, f2, compare them, identify which is the highest frequency, multiply it by 2, you will get the Nyquist rate, and divide 1 by, take the inverse of this, you will get the Nyquist interval. So, that is this algorithm, flowchart, or whatever you call, these are the steps involved. So, let us see what is f1 here. f1 is equal to 400 pi t by 2 pi. So, this is equal to 200 hertz. Okay, f2 is equal to 640 pi by 2 pi. So, this is equal to 320 hertz. So, we have identified this as Fm. Okay, this is the maximum frequency out of these two. So, Nyquist rate you can get this as twice of that. So, this will be equal to 2 Fm. So, this is equal to 400 hertz. Then similarly, you can calculate what is the Nyquist interval. Nyquist interval will be 1 by 2 Fm. So, this is equal to 1 by 400 seconds, whatever it is. Okay. But here you have to, if you want to, can divide this 1 by 400, give the answer in generally milliseconds or microseconds where is possible. So, you have to do this. Then the questions answer will be in milliseconds or microseconds, just calculate that. So, this is how you have to calculate the second part of this question. Let us see the example 1c. Okay, simple. So, Nyquist rate, how do you get the Nyquist rate? Nyquist rate is equal to 2 into 1000 pi by 2 pi. So, that is equal to, how much is this? 1000 hertz. So, this is the Nyquist rate. Similarly, what is the Nyquist interval? 1 by 1000 seconds. So, this is the Nyquist interval. It is as simple as this. Let us see the second example. The second example is as follows. Given a band limited signal in the frequency range of 22.6 kilohertz to 30.6 kilohertz, what is the minimum sampling rate required to completely specify the signal? So, you have been given a range of frequencies in this and you are asked to find out what is the minimum sampling rate. In other words, indirectly or directly, what you have to find out is we have to find out what is the Nyquist rate. Okay. So, what is given? Let us calculate what is the bandwidth of the given signal, which happens to be the maximum frequency of the given signal. Let us calculate the bandwidth first. Okay. What is the range of frequencies we have? Range of frequencies. Okay, 22.6 kilohertz to 30.6 kilohertz. The range of frequencies given are from 22.6 kilohertz to 30.6 kilohertz. Let us calculate the bandwidth of this. So, what is the bandwidth? That will be equal to 30.6 minus 22.6, that is 8 kilohertz. Now, this is our maximum frequency. So, Nyquist rate will be 2 into 8 kilohertz, that will be 16 kilohertz. So, this is the minimum sampling rate. So, what we have done, we have taken a bandwidth, given range of frequencies, we have found out what is the bandwidth, that is the maximum frequency of the signal. From that, we have applied the formula which we know. What is the formula which we know? Nyquist rate is equal to twice the frequency, maximum frequency, twice the maximum frequency. So, got 2 into Fm, that is nothing but 16 kilohertz. Let us solve this example 3. The spectral range of a function extends from 4.4 megahertz to 5.5 megahertz. Find the minimum sampling rate and the maximum sampling interval. Okay, so, we have to calculate both of them. So, what is minimum sampling rate? Minimum sampling rate is nothing but Nyquist criterion, and maximum sampling interval is nothing but Ts, that is sampling rate is 1 by the Nyquist criterion. So, that this, if this becomes minimum, this becomes maximum. Let us calculate this. So, we have been given from 4.4 megahertz to 5.5 megahertz, that is a range. So, what is the bandwidth? 5.5 minus 4.4, that is 1.1 megahertz. Okay, that is 1.1 megahertz. So, the Nyquist rate will be 2 into 1.1 megahertz. So, this is equal to 2.2 megahertz. Okay, that is 2.0 megahertz. And what is this? Is the minimum sampling rate. So, we call this as a minimum sampling rate. Okay, because Nyquist criterion says that it must be greater than or equal to 2 Fm. So, we are taking it equal to Fm, that is the lowest value. Now, calculate the interval. Now, what is the Nyquist interval? Nyquist interval will be 1 by 2 Fm, that is 1 by 2.2 megahertz, that is this is equal to 1 by 2.2 into 10 to the power of 6 seconds. So, this is the maximum sampling interval, that means we cannot have samples beyond this. So, this is the maximum sampling distance and this is the minimum sampling rate.